Hey, so we're going to study maths, and this is a brand new notebook, as you can see. So let's go on. This topic is called, the book I'm reading is Discrete Mathematics. With application with applications. And it's written by Susan S.F. Susanna. There it was. So, I've read chapter 1 and 2.1 till now, and from this notebook, I'll be starting 2.2, which is called conditional statement. So, hypothetical reasoning implies the subordination of the real to the realm of possible. Hypothetical reasoning implies the subordination of the real to the realm of the possible. I don't get it. Alright, I'm ready. Hypothetical reasoning. Okay, I think I get it. Implies the subordination of the real to the realm of the possible. By Jean Piaget. Piaget, 1972. So basically what this quote meant, the hypothetical reasoning implies a subordination of the real to the realm of the possible, means that while you are using hypothetical reasoning, you naturally assume that the real is just a smaller part of what is possible. So what is possible is a bigger part, and what is really smaller than that. So yeah. When you make a logical inference or deduction, you reason from a hypothesis. Your aim is to effectively say if such and such is known, then something or other must be the case. Let P and Q be the statement. The sentence in the form of P then Q is noted symbolically as P to Q. Okay, P then Q. It is called a hypothesis, and Q is called P is called the hypothesis, and Q is called the conclusion. For instance, consider the following statement: if 4,686 is divisible by 6, then 4,686 is divisible by 3. Such treatment is called a conditional because the truth of the statement Q is considered on the truth of statement P. Such notation P if P then Q indicates that is a connective, like carrot or a wedge, which can be used to join statement to create a new statement to define P and then Q for add statement. Therefore, we must specify the value for P to Q as specified the value for P and Q and Q and Q. And this the case is the formal definition of the truth value for Q is then P then Q is based on everyday intuitive meaning. Consider an example. Suppose you go for an interview at a store, at a job at a store, and the owner invites you following a promise. If you show up for work Monday morning, will get the job. Under what circumstance are you justifies in saying the owner spoke falsely? That is, under what circumstances are your statement false? The answer is if you show up for work Monday morning and you do not get the job. After all, the owner promises only says you will get the job if a certain condition is met. This is nothing about what will happen if the condition is not met. So if the condition is not met, you cannot in fairness say promise is false, regardless of whether or not you get the job. Another example is basically if P and Q. So if you come on Monday and you get a job, then that statement was true. If you do come for a job and you do not get the job, then the statement was false. If you don't come for the job and you do get then the statement is still true because the statement was if you come for a job then you will get, but it did not say anything about what would happen if you do not. So okay. And the final one is if you do not come, then you will not get. This is the most common sense one, I guess. Medical this game. Definition. If P and Q are conditional statements, if P and Q are statements, statement variables, the conditional of P by Q if P then Q, or P implies Q. Okay, and denote it by PQ. It is false when the P is true and Q is false. When P is false, P is true, and Q is false. Otherwise, it is true. We call P the hypothesis of the condition and Q the conclusion. Next thing, and take time. Give me a second, I want to ask. Okay. We copy the hypothesis or antecedent event or of the statement of the conditional statement, and Q is the conclusion. Conditional statement is true by virtue that the fact the hypothesis is false is often called vacuously true or true by default. A conditional statement that is true by the virtue of the fact that its hypothesis is false is often called vacuously true or true by default. Thus the statement, if you show up at work Monday morning, you will get a job is vacuously true. If you do not show up for Monday morning, in general, when the when the if part of the if then statement is false, then the whole statement is technically true. Okay, okay. So basically, let's try the same thing. The offer was, if you come here for a job on the Monday morning, you would get a job. But if you do not come here on the Monday morning, after saying that, then regardless of whether I wanted to give you a job or not, I would have still said true. I could still say I was correct, but you just didn't come. So it was I could say it is true by default or vacuously true. So yeah. Conditional statement on false hypothesis. Consider the following statement. If 0 equals 1, then 1 equals 2. As stated between, since the hypothesis statement is false, the statement as whole is true. Philosopher William von Orman-Quine advises against using the phrase P implies Q to mean P to Q, because the word implies that the Q can be logically deduced from P, and that is not the case. Nonetheless, the phrase is used by many people, probably because it's convenient replacement for the L symbol. And of course, in case of a conclusion can be deduced from the hypothesis, even when the hypothesis is false. My face. Truth table for okay. An expression that includes arrow sign as well as other logical operators such as arrow sign and or not. Conjunction, disjunction, or negation are the order of operations. The order of operation is that implied is performed last. Thus, according to the specification in the order of operation, it's performed first, then negation is performed first, and then the conjunction and negation, and then the implication, imply, then the conditionals, and the implies. Let's start with this one. So this is basically like a been used for Badmas rule, bracket, division, multiplication, addition, and subtraction. Yeah, so this is kind of like that. So the first one would be the negation, and this one, in this case, the first is negation, then disjunction and conjunction, and after that we would go to the conditionals, in which we are till now we're talking only about if then. According to the specification of order of operation of order of operation negation is performed first. And then and conjunction. And or disjunction. Disjunction. And finally truth table for PQ and this one. The truth table for PQ implies that the order of operations shown above following the question are equivalent to. Truth table for Q, a disjunction of negation of Q implies negation of P. Okay, I'm guessing that I need to set according to the order of what's the specification of order. Specification of order. And let's not bracket everything. So first would be P, and then negation of Q. So the first bracket, and then the second bracket, and then we did this, and it would be. Is correct? P, Q, yeah. In truth table, so first thing I want to check is once I selected P and Q and then negated it, then we did the hypothesis and we checked if it was true or false. Okay. First is P, then Q. T, 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 F, F, T, F, F. And then we will do the negation of P, which will be F, F, T, T. Negation of Q, which would be F, T, F, T. The next operation to be there was negation of P with the disjunction of a negation of Q. P with a disjunction of a negation of Q. I will show this to you in a bit. P with the disjunction of a negation of a Q. would be P with this. So true and false would be true. True and true would be a true. True and false would be a false, and false and true would be a true. And the final one I need is the negation. Yeah, I can just do the final dot. And the final is P with the distinction of a negation of a Q implies the negation of a P. So this implies this, true. This implies this. True implies false. Wait, how is it false? True implies true. True implies true would be true. So why did you put that in false? And true implies false. That is false. Yeah. Truth implies false. Yeah. That truth implies false is by default false. If I say I will give you a job and I don't, then that's truth implies false. That's the false. The next one is truth implies false again. That's again a false. The final one is false. The next one is false implies truth. And if there is false in any case, then the last matter, and then the section does not matter. If is false, then the then does not matter. It's always true. True. And the final is true, which is the back of course true. So that will be the truth table. And now I'll teach you. Wait, I don't think I can change the camera. Don't need camera. That's alright. Guys, okay, so these are my notes, and you only need this part. I don't know if you can see this or not. I don't know how good this is doing. So okay, now it's telling. This is the thing that you need to understand. Yeah, I'm guessing you probably do. Logical equivalence involving imagine that you're trying to solve a problem involving the three statements P, Q, and R. Suppose that you know the truth of R follows the truth of P, that the truth of R follows the truth of Q. So no matter what P or Q is, in that case, the truth of R must follow. The division into case statement method and analysis is based on these ideas. Example of division into cases. If P and Q belongs to R implies R, if P is disjunction with Q. P or Q implies R, then P implies Q and Q implies R. So what's that? First we fill the combination of the value of P, Q and R, then we fill the value of P, Q and R. Okay. The next problem is called division into cases. Showing that P or Q implies R is logically equivalent to P implies R and Q implies R. So to solve this, we will draw a logic table. So P, Q, and R. truth, 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 false, truth, false, true, truth, false, 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 true, true, false, true, false, 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 true, and false, false, false. I don't need any negation in this, that is good. The next is P implies Q. P and Q. P or Q. That would be truth, 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 and false. And P implies Q, that P or Q implies R would be truth and truth and truth would be truth, truth and false would be false, truth and truth would be truth, truth and false would be false, truth and truth and false would be false, truth and truth would be truth, truth, false and false would be false. No, false and truth will still be truth because I don't know what the answer is. If it is false, then if I didn't come for the job, then I would not know what the offer was. And if the shopkeeper intended to keep it, so I would have to assume that he was intended to keep it. And I just was lazy, so I did not get the job. The next is P, R, and Q implies R. Okay, so P implies R would be truth implies truth, true, truth implies and true, and truth implies false, truth implies truth, truth implies false, truth and false implies truth, false implies false would be truth, false implies truth would be truth, false implies false would be also truth. Truth implies false would be truth. No, it would be false. False implies truth would be truth. False implies false would be truth. Truth implies truth. Truth. False. Truth implies false. It would again be false. And false implies truth would be. Oh, I'm speaking now. False implies truth would be truth. No, it would be false. And false implies false would be truth. Then P implies R and Q implies R would be truth and would be and of these two. So that would be truth and truth would be truth, false and false would be a false, truth and truth would be truth, false and false, truth, false, false, truth. So are these not logically equivalent? Truth, false, truth, false, truth, false, truth. I don't know if this is true or not. This is false. There is one true and there is one false. One is false and true. So these are not logically equivalent, are they? Yeah, this one. Oh, they don't match. Oh no, wait, these two do. Now, this gets you phi f because it's true. And that's true. And true, that's true. P implies Q. P or Q. False and false would be false. False would be false and that would be false. Representing of if them as or. Sleepy. I did not sleep very well last night, so I'm sleepy as hell. What page am I at? Okay, I started from 76, I'm at 79. My goal by tonight is to... I also have to study C though. Can't really finish this. Let's finish page number 80. After that I have to study C. I should go and make some coffee.